All right, good morning, everyone. Hopefully you can all hear me nice and clearly. So it's just clicked over 9 o'clock, so I'm going to kick things off. So it's 9 o'clock. This is a double session, so hopefully you've got your learning caps on. There's a lot of content here, so hopefully you're learning lots. That's kind of the aim. So I'm here to teach you about how to unleash your PowerShell using AWS Lambda and serverless computing. So I'm Andrew Pearce. I'm a Senior Systems Development Engineer with Amazon Web Services. Now, I work in our corporate systems organization where we focus on the design of the internal network for Amazon's global corporate network. But in this role, we're lucky that we can sometimes work closely with our product teams to help deliver features and capabilities for our customers, you guys. And so for me, I was lucky to work with our SDK team on the implementation of PowerShell Lambda. So I'm very passionate about this, so I'm keen to be here and share some knowledge. So what can we expect from today's session? Well, firstly, who here has used Lambda before? More than I expected, good. How many have used PowerShell in Lambda before? Not so many, awesome. Hopefully there's lots to learn. So we'll start by baselining some knowledge of Lambda to make sure everyone's kind of on the same page before we dive in too deep. And we'll introduce the PowerShell implementation and how it works, how you can develop for it, and some of the interesting features that we've added in the tooling for this. We'll then talk about serverless and event-driven computing. Now, these may seem like new patterns to you, but you've potentially been doing a lot of this already in your current jobs with event-driven computing. So I'll sort of tie back to what you may have used today already. And at that point, we've gone through a lot. So I'm going to switch gears a bit and demonstrate what a serverless application looks like when developed in PowerShell to really help drive some of the reasons and benefits of developing in this nature. So what is Lambda? It's probably kind of the first question. Lambda lets you run code without provisioning servers or managing servers. This is really one of the key points of Lambda. Every time you want to run PowerShell code today and you decide to choose a Windows server to run it on, think about all the operational work that goes into making that happen. Someone has probably raised purchase orders to buy hardware. You've racked hardware in your data center. You've cabled it. You've installed a hypervisor, you configured LUNs on your storage, you've installed a virtual machine, you've installed Windows, you've joined it to your domain, you've added monitoring software and antivirus software, you've made sure your group policies are applying, you're patching that every month, you're patching your vendor applications every month, you're applying antivirus definitions all the time, and you need a decommissioning story for all of that. So just by choosing to run a server, to run a PowerShell script, you are signing up to a whole lot of operational burden. And that's not fun work that really anyone likes doing. So this is a way to just not do that. Just write some code and have your code run for you. We have a term called undifferentiated heavy lifting. That's what all of that work is. That doesn't differentiate you from the next guy. So let AWS do that, because that's our business. Now, Lambda scales automatically. When you develop an application, often you don't know the load of your application until you start getting customers using it. So how much hardware do you buy? How many virtual machines do you run? With Lambda, you don't think about that. It scales automatically from nothing to many, many thousands of executions and back to nothing in a really short period of time. Now, Lambda can be invoked directly through an API. So you can invoke it from PowerShell, from any of the SDKs that AWS releases, or it can be invoked in response to an event. And this is really where the key architecture designs come in when you're developing in serverless. And additionally, you're only paying for the time that you're actually consuming the service. When you run that server and doing all that operational work to run a 5-minute PowerShell script, you're basically paying for power and compute for 23 hours and 55 minutes a day that you're not using it for. So why do it? Lambda lets you run that, and you pay for those 5 minutes that you're using it for, and that's it. You walk away. So don't pay for idle, right? This is one of the key points here. You're not paying for idle time of compute and memory and cooling in your data center and all the other things that go along with that when you're running in Lambda. So what about PowerShell in Lambda? Right, we're at a PowerShell conference. Let's talk about that. So in September of last year, AWS launched PowerShell language support in Lambda Now this is a production service. This is GA, open to everyone in the public. You can go and develop on this today, and it is running production workloads today. There's no over the horizon, this is coming, right? This is here right now. Now it does use the .NET Core 2.1 runtime in Lambda. So this is actually a C# application that you'll be deploying. But we released a new module to the PowerShell gallery called AWS Lambda PS Core that abstracts all of the .NET and all the C# stuff for you, and you just see PowerShell and develop with PowerShell. And that's just kind of taken care of for you. You can choose the PowerShell version you want to run, and that's kind of cool. The tooling defaults to a language in the a version in the module, but we use the Microsoft PowerShell SDK NuGet package that the PowerShell team publish. So any version that they have published to NuGet, you can use that version in Lambda. So 6.1, 6.2, 6.1 preview 4, take your pick. You can choose what language and what version of PowerShell you want to run. It's also open sourced. Everyone loves open source software. The entire PowerShell implementation for Lambda is open source. So go and look at the code. The PowerShell module is open source. The PowerShell host that we execute within is open sourced. So if you have concerns about what's happening, go and look at the source. File pull requests, file issues. Now, we want to hear what is going wrong in your environment. If something is, we want to hear what's going well. So let the team know what is happening when you're using this. So let's talk about what it looks like when you develop. And I'm going to go over the experience of using this, and I'll demonstrate that so you can actually see it in practice. So the input to a Lambda function is JSON. JSON in, JSON out. But with the tooling for this, we do a bit for you to make it easier. So we predefine two variables. The first is Lambda input. This is a PowerShell object that is literally the input JSON using convert from JSON to give you a PowerShell object. So in your PowerShell code, you have an object. You don't deal with JSON if you don't want to. The second one is the Lambda Context. Now this is unique to Lambda that provides information about your running container. How long you have left. You give it a runtime up to 15 minutes per execution. So you can query this to find out how long you've got remaining, or where to find the logs for this function. You may not even use this in your code at all, but it's there in case you need it. And additionally, which I'll demonstrate, you can develop a script or a function for PowerShell Lambda. And so if you define a function, we simply take two positional inputs that are these two objects. So when you develop your function, just make sure you've got the two input parameters, and it'll work just like you expect. Logging. Logging in serverless can be a challenge. There's lots of logs. If you're processing billions of events, there's going to be lots of logs. But for the PowerShell implementation, we send all the PowerShell streams to logs for you. Essentially, anything that touches a console will make its way to a log. So all the write commands work really well. And write host is actually really good in this situation because console is exactly what you want for logs. So don't be scared of using write host when you're developing PowerShell Lambda functions. It does exactly actually what you want it to do. So the .NET tooling on this is really helping where, because it's a C# application, we can hook into the PowerShell streams and catch those events and write them to logs for you. So that's how this is actually happening in the background. The C# application is actually doing all that heavy lifting for you. Output. So a Lambda function is not a PowerShell script that has a pipeline. Right? It's a web service API call. There's no pipeline you can throw data to. This is a web request. There's a response. So in this tooling, the last object on the pipeline, in the output stream, I should say, is what's returned from the Lambda function. Kirk had an interesting idea yesterday that if you want to guarantee that you really know what you're returning, use the return statement and just break out of your code whenever you want and just say, this is my return object. Hand it back. Now, I said JSON in, JSON out. So if you hand a string back to the tooling from the Lambda function, that is handled as is. We don't touch it at all. We will hand that string back to the caller how you want it. So the keynote here is if you're handing back an object with lots of depth, handle it yourself. Because we use convert to JSON to hand back any other object to the caller. So a default convert to JSON, if you're fine with that, just throw a PowerShell object to the output, and we will convert it for you in the tooling. So this is a very PowerShell experience. Right? We're trying to make sure you are PowerShell developers. You can develop in PowerShell in VS Code. You don't have to see .NET code anywhere if you don't want to. So let's have a look at what this looks like to develop and deploy a Lambda function. Yes, it disconnected. So I'm running this in a workspace purely because this is a C# application, right? It could be 5, 10, 20 meg, depending what I add to my package. I don't really want to publish that over the Summit Wi-Fi, so I'm doing it from EC2, so it's a bit quicker. All right, let's turn some things on here. Set myself up. So I mentioned we had this new module on the gallery. It's our tooling module. You definitely need this to do it. The interesting fun part here is I had a developer slide, which apparently isn't my deck anymore. So I'll cover what you need now. You need PowerShell core. This is PowerShell core that is running in Lambda. You need this module, because this module wraps all the .NET commands for you. You need the .NET SDK, because you are compiling a .NET application behind the scenes. You probably want the AWS PowerShell modules if you're going to communicate with other AWS services, but it's not required at all. And that's all documented also in our documentation guides. There's some really nice blog posts that really outline exactly what you need as a requirements to do this. So let's have a look at the module. There's only 4 functions in here. The first one, get AWS PowerShell Lambda template, gives you a list of what blueprints and templates are available to speed up your development in Lambda. There's boilerplate code for standardized events, and why write that code every time you write a Lambda function? So these can help you get up to running more quickly. And if you are developing these and you come up with a really good blueprint, file a pull request to the repository. And Nate did one for the CloudFormation blueprint, and hey, everyone has it available now. And I think that took a day to get published by the team. So they're very responsive to this. And if you have good templates, please file them and help everyone else out. New AWS PowerShell Lambda will create a new Lambda script based off those templates. It literally just copies and files out of the module. I'll talk about publish first. So publish AWS PowerShell Lambda will take your PowerShell script, package it into a .NET application, deploy it to your AWS account, and make it available to you straight away. This is great for development where you just want to take what you have, push it up to the cloud, and invoke it. New AWS Lambda package, on the other hand, is more for CI/CD pipelines. So where you have a continuous integration build step where you want to build an artifact that gets deployed in a later step, this will create that artifact that you can reuse further down the line. So if we look at what blueprints we have available, there's a few here, and these cover some of the really common development things you'll do when you're building serverless. So S3 events are one of the most common design practices we see. SNS and SQS are, again, I'll be demonstrating these today. These are some of the most common things that we see in development today with serverless. So let's deploy Lambda function. We're going to create a new Lambda function off the basic script. And let's go and have a look at what that looks like. So we created this PowerShell script. This is a basic template. It gives you some overview information, such as those 2 variables that I explained before. It outlines some details about the require statement. Now, I'm not going to talk about this just yet. I'm going to talk about this in 2 demos' time. So for this demo, hello world, let's just literally return hello world from a Lambda function. So I'm going to deploy this to my account using the publish AWS PowerShell Lambda script. I'm going to hand you the name of the function I want to deploy and the path to that script. And you'll see here that this is if you've used the .NET tooling before, this is using the .NET CLI in the background to package up all the requirements for this Lambda function. So this takes a few seconds, clearly. Apparently I kept the AWS PowerShell module in there. Awesome. All right, now it's asking me for what's called an IAM role. AWS security is number one. So by default, the Lambda team, the Lambda service itself, doesn't have permission to execute a Lambda function in your account. You have to explicitly grant them permission to be able to do this. On top of that, your code that you write, maybe you want to talk to an Amazon EC2 instance. That you have to grant that function access to make that API call. So this is about granting your code, your Lambda function, what it can do in your account. So I've created, there's clearly a bunch here. I'm going to just use the Posh Summit demo one. This doesn't necessarily work in VS Code too nicely. So there you go. All right, I have a function created. Let's invoke the function. So I've deployed the function. I'm going to invoke it. So I am going to use my convert module that's on the gallery to simplify the output. The invoke lm function command is in the AWS PowerShell module. Now this returns a memory stream object. That's what all the SDKs return, and the modules are generated the same as all the SDKs. So the payload is a memory stream, and the log output is a base64 object. So I've made this module that you can just pipe to convert to string to just simplify that conversion. Yes, the whole line, please. Let's invoke that. So this is a cold start. So this is standing up, I'll call it a container for now. This is standing up a container, deploying my Lambda function to it, initializing the session, and invoking my Lambda function. And that took, what, 4 seconds. So that's a cold start. And if we run that again, you'll see that a warm execution is very fast. And if we look at our payload that came back, apparently I got nothing back. Sweet. Let's go and look in the console, because we're all Windows guys, we like our UIs, so let's go and have a look at what got deployed. If I can type. So I'm going to come into the services, I'm going to go to Lambda. I deployed the demo1 basic script function. I'm going to invoke this with a test input. Now, clearly we know this is going to say hello world, so this is ignored entirely by my Lambda function. So I'll create my test and invoke it, and you can see that apparently I got nothing back. Don't you love when demos go well? And I know why, because I never saved my Lambda function. Right, let's do demo number 2 to demonstrate it. Let's use a Pearce object. So Pearce custom object, let's say output equals hello world. So in this instance, we will actually convert this to a JSON for you, unlike the last demo which failed, where we didn't. So I'm going to publish this again, and then we'll invoke it again. So at least what you're seeing here, even though that failed, is this is just PowerShell. Right? I'm not leaving VS Code really, I'm just doing this all from PowerShell. It's a PowerShell script file. Nothing is out of the ordinary for a person that writes PowerShell code. So let's invoke this again. Again, there's a cold start because I changed the code. Question?
If you import your own custom modules and stuff, it'll just package those up.
Yes. I'll talk about that very shortly. All right, there you go. So I actually got an output this time around, so that's good. Yes, so I'll come back to the question anyway in a few demos. All right, so there's a PowerShell script. So I mentioned we can use functions, and a lot of us in the PowerShell world are trying to kind of move past scripts, right? We're kind of trying to create functions that we can test in CI/CD pipelines and validate they're going to do the thing correctly. So we made sure we could support functions in this implementation. So let's have a look at what a function looks like. So this is a PowerShell script. It has nothing but a function defined in it. I've got my 2 input parameters. You can name these anything you want. They're positional parameters we use. Now in this example, I'm going to use a bunch of the write commands to demonstrate log output for you. I'm not going to use write error because that will be terminating and throw an exception for my Lambda function. But if you want to do that, you can throw his right error if you want. And again, some simple logic. Right? This is a PowerShell script, so all my standard logic will work exactly as you expect. So if I hand in an input with a name parameter, I'm going to say hello name. So let's set this up and deploy it and demonstrate what this looks like. So I showed you that. To save me having to select my role, I'm just going to choose it now so I don't have to do that later. Now the main difference here is I'm using this PowerShell function handler parameter. In fact, if I make that bigger, you can see that better. There you go. So I've got this PowerShell function handler parameter. All this is going to do is set an environment variable on my Lambda function. And if that variable exists, the tooling will use that function to invoke your code, as opposed to the script. Now, it runs your script, so anything you do in your script will be brought into memory. So as long as you expose a function, that function can be used in Lambda. So this is how you can really integrate nicely with CI/CD pipelines. So I'm going to publish that. No, I'm not, because I didn't set my function name. This is what happens when you skip ahead in your demos. All right, let's publish that. So again, this will publish it. You can see, if you caught that it's setting an environment variable. And when this is published, I'll invoke it. So the only difference in this invocation is I'm going to hand in an input payload. So the input payload is a string parameter. So I'm going to create a JSON. And I'm going to specify the log type of tail, which means I want to get the log output back in my from my PowerShell execution. So you could see this in the console, or this is how you can invoke it and get the logs back as well, so you can view them. So we'll invoke that function. Again, some slight delay from a cold start, but that's okay. And if I look at my log result, wow, this is working really nicely. There we go. All right, so right host worked. I got my right host output. I got my verbose, my information, my warning. So anything you throw to those streams will come through logs for you, and you don't have to think about it. So that's really nice. In this output, you can see the amount of memory I used. So this is a good way to identify how much RAM to assign to your Lambda function. Because the few things you have control over is your memory constraint. And your memory constraint defines how much CPU you get. There's no explicit, I need 3 CPUs and I need 2 gig of RAM. You simply specify an amount of RAM, and that is a linear allocation of amount of CPU to your function. You can define 128 meg minimum. I would recommend for PowerShell 512 minimum, or maybe 384. But you can go up to 3 gig. So if you have some high memory requirements, you can run 3 gig of RAM in your Lambda function. Now my payload response said how by PowerShell Summit, because I handed in a name of PowerShell Summit. So this is just some simple PowerShell logic, but it is just like you'd expect. This is just PowerShell. So I mentioned we can do modules, and this will respond to the question of how to package custom modules inside your Lambda function as well. So for this demo, I'm just going to set my folder first, because I forgot to do that before. And let's open up some files. So this is just a PowerShell module. All right, here's a module manifest. I'm exposing a function out of it. Nothing fancy there. I've got a PSM1 file that has a function in it. It's exactly the same function before, just a different name. Nothing fancy there. We've all made modules before. Now this is the key one, my script that I'm using. All right, my script. This require statement is a really key point in the tooling for PowerShell Lambda. Most of our code relies on third-party modules of some sort, whether they're developed in-house, whether they're developed by someone else on the gallery. So when we package your code up to deploy it to Lambda, we want to package all its dependencies with it, because you don't want to invoke a Lambda function that then takes 30 seconds to reach out to the gallery and download a module and install it before your code runs. That's kind of an anti-pattern in this world. So the tooling uses the AST of your script, passes the AST to find out what required statements you've defined and uses that to identify what you need. So the first thing we do is it looks in memory. Can I find the module you need in memory on my build, wherever I'm running my build from? This is really good for CI/CD workloads. In your build, you're going to test all your dependent modules, import them. All right, make sure you import the module you're testing. So you're definitely going to package the module you want. Now, if we can't find it in memory, we're simply going to look in your system, because like AWS PowerShell, it's a very large module. It's something like 20 meg unzipped on disk. Why download that if you've already got it locally, right? So we're going to look in locally on your disk, and if we can find it, we'll use that first. But if you can't find it, we'll reach out to any repository that's registered on your system. This could be the gallery. This could be a private internal repository. It'll reach out to any and all and try and download the package, the module. But if you want to force that to a defined repository, so if you do have an internal repository and you only want to talk to your internal repository, in the publish commands or the packaging commands, you can specify a repository, and the tooling will only look in that repository. So this is one of the really key points when you're developing for Lambda. This require statement is actually why you must have a script. Even if you have a module, you need a script to tell the tooling what modules you need. So I'm going to deploy this. This is the same as last demo, right? Except I'm going to be invoking code from a module. So as before, import my role. I'm going to make sure I remove the module from memory, import that module back in memory, and show that this is the path to my module. So right, I've got this module path here, and that will be used in the packaging. Now for this demo, I'm also not going to do a publish command. I'm going to demonstrate the packaging. Because this is, again, once you, right, we're all trying to move to CI/CD worlds. We're all trying to move to Git-triggered workflows. This is what you'll use in your CI/CD pipeline. You likely won't do a direct publish to your account. So I'm going to use a package command. Now I didn't splat this, but there's really nothing I'm adding here. Right? It's a script path and a path to a zip file. Nothing else required. This will do the exact same packaging process as the publish command, but it will create a zip file. Now that zip file could be deployed through a number of different ways, but it also tells you some details that you need. So if I actually go into a list, when you use the publish command, this is kind of taken care of for you. Because this is a .NET Lambda function, it is not explicitly a PowerShell Lambda function. You need a handler that defines the path inside the .NET application to the method to be invoked. The publish command does it for you. The package command tells you what you need to use when you deploy it. And it's also saying if you want to define a PowerShell function, to use this environment variable to define that Lambda function, the PowerShell function. So for this demo, I'm going to publish this up to an S3 bucket. So S3 is Amazon's simple storage service. It has 11 nines of durability. It's a really great place to store objects for use down the line. And I'm going to publish this using the PowerShell commandlets in our AWS module. And you can see there's a whole lot more involved than a direct publish. This is why when you're just demonstrating and developing and reusing it, just use the publish command, just throw it up to your account. But in a CI/CD pipeline, there's a little bit more involved. And you probably won't actually publish with this. You probably use like CloudFormation, define it in code and deploy it through more defined processes. But you can do it this way. And you'll note I am saying my runtime is .NET Core. Right? This is .NET Core. So I'll invoke this, and just like before, you'll see the same outputs on my console because this is the exact same code. But it's in a module. And you'll see at the top here that it imported the module that I defined, and it configured the call to the function from the PowerShell script. So this is in the log, so when something goes wrong, because let's face it, as you're developing and learning, something probably will, it tells you what it's doing, so you can go and troubleshoot that and find out what it's doing. And I know I've done this, and I haven't exported my function, and clearly it throws an error because it can't find my function. So this was really good because it was like, hey, I can't find this function, it doesn't exist. Cool, I probably should export that. That would help. All right. So PowerShell Lambda, it's just PowerShell. It's nothing different to what you develop today, whether you're using scripts, functions, modules, however you develop your PowerShell code today. This is just PowerShell. So let's go back to the slides. So what did we learn? As I said, it's a script, functions or modules. This will likely fit into your current build processes you do today. Whether it's local development, whether it's a CI/CD pipeline, the same things you're doing to test your PowerShell code can also be used to test your code you want to run in Lambda. There's nothing different. You can directly publish straight from your PowerShell console to your account, or you can compress your archive to deploy through other deployment mechanisms. And at the end of the day, it's PowerShell. Right? This is nothing fancy. So that's kind of a really key point that I want to drive home here. You're not writing .NET applications. Even though it deploys one, you're just writing PowerShell. Right, section 1 done. You all kind of know what PowerShell Lambda is now. You know what Lambda is. We've seen it invoked. What about serverless and event-driven computing? Now, these are two terms that get thrown out quite a lot in the cloud world. So let's kind of define them and give you more of an understanding of what they are and why they're key to developing in cloud. Serverless. It is the native architecture of the cloud. For all those reasons I stated, that you're not racking hardware, deploying operating systems, configuring operating systems, deploying antivirus agents, configuring definitions, doing security patches and zero-day patches, and decommissioning servers, and then having runbooks to redeploy servers. All of that is gone. You just deploy an application and invoke it. So this is how you deploy native cloud architectures. And it's because of this reason. You're shifting all of that operational responsibility to AWS. Why do that undifferentiated heavy lifting when AWS can do it for you, and you can just innovate and build and do all the fun things? Serverless scales for you. Just like Lambda, serverless technologies scale on your behalf. You don't have to think about how many people are going to be invoking your API in a day's time, in 3 days' time, in a month's time. The platform scales for you. So that's just thoughts you don't really have to think about a whole lot. And automated high availability. Don't know about you, but I hate single points of failure. I hate it when one little thing in my application fails everything. So AWS has a concept of regions and availability zones. I'm sure you've all heard this before, but I'm going to define it just to make sure. AWS has about 20 regions, 21 regions around the world today. Every region has at least 2 availability zones. And these are groupings of data centers with discrete power, networking, compute, storage. Everything is isolated between those availability zones. If you deploy your application to multiple availability zones, just running in 2 completely separate data centers, your application natively becomes more highly available. The service teams that run Lambda, all the AWS products, deploy highly available by default. So by leveraging serverless, you are building a highly available application without even having to think about it. So that's a really cool point. And because you're doing all these things to hand off all these workloads to AWS and not thinking about operations or high availability, you are ensuring that your focus is on your customer and your customer's needs. Because you're not focusing about servers and operating systems and config management. You're focusing on your application and what you're deploying and your business logic and what makes you different. So serverless is great for that. And event-driven computing is kind of along the same lines. Your code, your Lambda function, is triggered in response to an event. Now, this can be quite a confusing concept for people to start with. But have any of you looked in your event viewer in Windows, right-clicked an event, and said attach task to this event? That's event-driven computing. An event was raised on your Windows system. It created a log. That log entry invoked code. Event-driven computing. How many of you run SCOM and configure alarms? Those alarms are events that trigger a downstream action. Event-driven computing. You're not running a 24/7 polling application that's constantly asking for things of what's available, do I have something to do? You're just saying, when you see this, run this thing. So a lot of you already do this today. Right? We're just moving this up the stack into AWS so you don't have to run it on your own infrastructure. Event-driven computing gives you loosely coupled systems, and this is how you build reliable, repeatable platforms. This is why you use those events in SCOM. This is why you don't run code to constantly query SCOM to look for an action. SCOM's doing that already. So by building loosely coupled systems, these are asynchronous calls to each other, and you're not waiting on something to happen to give you a response. You're just triggering this thing, and that thing's going and doing its bit of work, and might trigger the next thing. But each of those discrete little microservice bits of code can scale independently of each other. So if something takes 10 minutes to run, great. It will have more concurrent executions. If something takes 100 milliseconds to run, that work will be done really, really quickly and handed off to the next thing. So loosely coupled systems and using asynchronous architectures is what event-driven computing is all about, and it's how you build more reliable systems. And just like serverless, it scales for you, so you don't have to think about how much hardware to buy. This scales in response to the amount of work that's coming through your system. So again, don't pay for idle. No one likes paying money for things they're not using, so don't do it. So S3 is a really good example for this. As I said, S3 is Amazon's simple storage service. It has 11 nines of durability. It's built highly available. You can replicate data from one region to another by checking a button and turning it on. This is a really great place to store things. Logs, configuration files, software. It's one of the best places in AWS to put that stuff. And S3 raises events. So let's say you have a company that processes images. You get an image in, it's a really high 8K image. You want to convert that to a thumbnail for your website. You want to convert it to many different scales depending on what people want to use, if you're on a mobile phone, if you're on a tablet, a computer. You put your object in S3 bucket, it raises an event, and multiple workers go out and convert that image for you. You're not polling for work. Your object's already in a very durable data store. So this is a really common workflow we see all the time. But what I've got here, S3 bucket to Lambda, that's not really scalable. Right? That's one-to-one mapping. One object, one execution, and that doesn't really scale. So let's throw Amazon Simple Notification Service in the middle. This is a pub-sub notification service where you can separate publishers and subscribers, just like all software developers do today in their own applications. And this can fan out that message to multiple pieces of work. So as I said, image comes in. I have 100 different workflows to convert that to many different image formats. Using SNS, my one object triggers 1,000 executions of Lambda, doing different things. The challenge here is if one of those Lambda functions fails, you have to know how to retry it. Otherwise, you've just kind of missed an image. And that's not fun. So if we expand this again, this is what I would more commonly see. So SQS is simple queue service. This is a queuing platform that allows you to decouple and scale services independently from each other. It has really good retry capabilities. So if your code throws an exception, you can configure this to put the message back in the queue to be processed again. And if you fail to process that message too many times, it can be put in what's called a dead letter queue, which is just another queue of like failed messages. So now you can get really good understanding of what's working in your system, and you get examples of what's not working in your system. And this allows you to scale each of those workflows independently from each other without worrying about that failure and what do I do if it fails. So this is what I deploy, and this is, if you look at the use cases in the Lambda website, this is what the vast majority of sample serverless Lambda-based use cases use. It's this SNS, SQS architecture to fan out and give really good retry capabilities. Right, let's look at that. Let's see how this works and actually demonstrate it rather than talking about it. While I'm flicking over, does anyone have any questions at this point? Or is this just like information overload? Good. All right, let's come out of presentation mode. If my keyboard decides to work, and open up the next demo. All right. So again, we'll look at what blueprints we have available. And we can see that there's 4 different ones here for S3 events. these are those different S3 event patterns I just described. S3 directly to Lambda is the first one. S3 to SNS to Lambda is the second one. S3, SNS, SQS, or you can just go straight to SQS if you don't want that fan out. If you're going to build with this, I'd recommend putting SNS in the middle, even if you're not fanning out today. Because who knows what your customers are going to ask for next week. They may come along and say, I actually need this thing from that data set too. And if you don't stick SNS in the middle now, you have to re-architect that to support that. So just throw it in the middle now. It scales, like, don't worry about the scalability of that. It's used on Amazon.com behind the scenes. It will scale to your needs. So I'm not going to demo with that first, though, because why do that? So I'm going to just demo an S3 event. So let's create a template, a script based on an S3 event. Apparently. Oh, yes. All right, where to go? Here we go. S3 event. All right. This is the template for an S3 event. At the top, all the same documentation we had before, the same details describing some of the things for you. Lambda input objects, the last item is returned. We have a require statement. This does use the PowerShell module from AWS. But if you actually look at the code, there's really not much here. Anytime you leverage these eventing capabilities, you will always retrieve an array of objects. Even if there's only one, it will always be an array. So that's just one thing to note, but this does it for us. So for every record I get, find my bucket and my key. You can think of this like a drive and a file. Bucket is my drive, key is my file. This is the path to my object. For every object, I'm just going to get the metadata from the object and write the size of it to my logs. And the one keynote that you probably note here is there's nothing being returned. This is not a synchronous invocation where I want a response. This is some asynchronous thing that's happening off the side. There's nothing calling that. There's nothing waiting for a response from that. So you don't have to return anything here. The output of this function is actually writing a log. So just remember that you don't need return data when you're writing Lambda functions. So let's deploy this and write it. So I'm going to package it and make sure my paths are correct, because that clearly wasn't working too well before. So does everyone understand like this eventing kind of workflow? I hope you've kind of used these capabilities before, so it's not really new to you. It's just new in this context to you. All right, so same as before, I'm going to write this and publish it to my account. And for this demo, I clearly need a bucket, right? This whole demo is based on writing an object to a bucket. So I'm going to create a bucket. And then I said security is number one on Amazon and AWS, and it really is. I have a bucket, and I want this bucket to trigger my code in my account. It doesn't have access to do that. So by default, S3 can't invoke things in your account. So I have to explicitly tell that the S3 service, when running against this particular S3 bucket, is allowed to invoke my Lambda function. So this is kind of some of the gotchas with AWS, that it is secure by default, and nothing can happen without you explicitly granting it access. So I've given permission to my bucket to invoke my function. Now I actually have to tell it to invoke my function. So I'm going to write a notification object to my bucket to say trigger this every time you get an object written to the bucket. Now all these samples will be on my GitHub probably over the weekend. So don't worry about screenshotting or anything. This will all be up there. All right, I've now got a notification. Let's go and look before I write an object, and we'll go and look at what I've actually done. So let's put an object in my bucket. I'm just going to write a text file with some content, and that's my bucket. So what's happening right now is S3 has raised an event, and that event has triggered my Lambda function with the input reference to this object. My Lambda function will go and get the metadata from the object and just write the size of that out to its log stream. If we go over to my UI again, I'm going to go over to the S3 service. and sort of show what has happened in the console, because it's a bit more visual, so you can see what's happened. So, May the 1st, this is my S3 bucket. I have an object. I'll make that a bit bigger. So here's my object I wrote. We can see in the UI it's 24 bytes, so we'll see that in the logs shortly. If I come over to the properties of my bucket, I've configured an event. Now, this is what I set up. So I have an event that is saying on a put event, trigger Lambda. So this is what I did with those few lines of PowerShell. You can do it all in the UI if you want. I don't recommend it because it's not repeatable, but you can if you really want to. So that's all I've done. So let's go and look at the output from Lambda and see what happens and make sure that we get that entry in the logs. So I'm just going to query the output from that Lambda function, and you can see that I processed an event from my bucket, and it was 24 bytes. So that'll happen in the background, happen asynchronously. I don't care about this, particularly me as the person that put something in my bucket. This is just some downstream workflow that just happened because I needed it to happen. So that's that simple use case of S3 to Lambda, but as I said, don't ever do that. Always stick queues and things in front of it. So let's look at that. You'll note this demo is going to be really no different. The only difference is multiple functions are going to execute behind the scenes. So I have pre-deployed some infrastructure for this. It can take a few minutes to stand up some of these things, so I've just done that in advance. So again, if we look at our templates, I've used in this example the SNS template. And I'm going to open this up and show you what that looks and see the differences of why these blueprints can really speed you up. Again, basically the same comment at the top. We have a require statement. But the difference is here, you're seeing that there's records inside records inside records. Right? S3 went to SNS, which wrapped up all the records. It went to SQS, which wrapped up all the records, and then made its way to Lambda. So this blueprint just unwraps all of that for you. So I'm unwrapping an SQS event firstly. I'm pulling out the SNS event for it, and I'm processing each SNS record to find the exact same code we saw before, because that's the actual S3 event that I want to process in this record. So these blueprints just can get you up and running so much more quickly than trying to figure all this out yourself, because then you need to go and look at what the events really are and figure out that unwrapping yourself. So I have deployed this already, I hope. So I'm not going to deploy it again. But these template commands will do it for you. Now, you'll see this in the blog posts for AWS Lambda. This is using CloudFormation to deploy it. It's a very repeatable pattern. CloudFormation is YAML or JSON templates that allow you to define AWS resources as code in repeatable deployment patterns. And these CLI commands from the AWS CLI can take your locally packaged zip file, upload it to a bucket for you so you don't think about it, and then you can deploy that template. And it will update the template with all the references and all the things in place. But this is in some of the blog posts about AWS Lambda, so that's the best place to really go and learn about this. So again, let's write an object to my bucket, and it's not very exciting at this point. And we'll be able to see that we're getting outputs. So just like before. Now, I ran that really quickly that time. And you'll note that my logs aren't here yet. These my Lambda functions already run. The logs are not real time coming out of Lambda. So just be aware of that. The logs, this is likely, I don't know for sure, but it's likely going through the CloudWatch backend through queues of their own, and they're processing everyone in the world's log messages and asynchronously writing them to your logs. So it's not real time to make its way to the logs. So just be aware of that when you're trying to demo this and test it. So just like before, object was 24 bytes. So that's not very exciting, but that was on log root 1 from Lambda 1. And again, not very exciting, but Lambda function 2 also wrote my output as 24 bytes. So I wrote something to S3 and 2 separate pieces of code invoked. They may have been the same code in this demo, but they could be completely different workflows in your environment doing completely different things from their data set. And if I trigger this a whole bunch of times, the same thing's going to happen. All right, this will fan out and execute multiple times. Yes?
Excuse me. How much or how long are logs maintained for your Lambda functions?
So the question was how long are logs maintained for your Lambda functions? That is completely up to you. By default, indefinitely. They will be stored in Cloudwatch logs completely indefinitely unless you tell it otherwise. And you can define lengths of time to roll those logs out. So you can say, keep them for 5 minutes, and the service will do that for you and just roll the logs out for you, and you don't have to think about it.
Does it set up the Cloudwatch log capture by default when you create a new function, or do you have to set that up?
So does it create the Cloudwatch log capture for you by default? If you've given your Lambda function permission to create the log group and to create the log stream, yes. You can create it yourself in advance. You want at least create log stream because every container in Lambda will write its own log stream. So you want at least create log stream permissions in that role you've given your Lambda function. If you don't, it can't create a log because you haven't given it access to write the log. But as long as you give it those actions, yes, it will create all of that for you. So I've worked this lots of times, and clearly we've got lots of logs in my output referencing all those different files. So this is a great way of deploying an application and kind of just letting it run on its own and scale on its own. And your customers might be putting objects in your bucket for you. So you're not even in that workflow. They may be doing that on your behalf. So you can deploy this, and it can just run on in the background. It's posting metrics. It's posting logs. You can watch it. You should be watching it. But you can do that through dashboarding and alarming. And you're not day-to-day interacting with this service. And it will scale almost indefinitely for you. You don't think about it. So let's flick back to the slides. Because S3 can raise an event, and that's great. But there's not very many things, right? That's one service, and that's not very useful. But there's lots of services that integrate with Lambda. So if we look at some of these services, right? AWS IoT button. Go buy a button from Amazon, and you press your button, and your Lambda function runs. That's kind of cool. Code commit is a hosted Git service from AWS, so a private Git service. Every commit in that Git service can invoke a Lambda function. Code deploy. This is a way that you can deploy code to fleets of machines or Lambda functions in blue-green type scenarios. That can invoke Lambda for you. CloudFormation, as I said. So CloudFormation, right, here's a fun one. AWS resources in CloudFormation is how you define things through code. Well, what if you could write your own code to literally build anything you want through a CloudFormation deployment? And you can, because CloudFormation can treat Lambda, and Lambda is your code. So you can actually use CloudFormation to define any platform you want as long as you can hit that platform from Lambda. You have a third-party vendor application with an API. You can deploy it through CloudFormation and actually hit their API and control it through code from CloudFormation. So that's a pretty cool capability. So there's a few things there, right? There's what, I don't know, 16 or so. And that's also not that many when you think that there's like 160 plus services in AWS. So Cloudwatch is a really interesting one, because Cloudwatch has a service called Cloudwatch Events, which is kind of what you expect. If you look at their documentation, all of these things can also trigger your Lambda function. And if you look at these, the very, very last one is Cloudtrail. So Cloudtrail is a service that logs all API calls to your account. All of those are events that you can raise Lambda functions off. So if someone creates an RDS SQL Server database, you can trigger Lambda. If someone creates a registration for a hybrid systems manager agent, you can trigger Lambda functions. So almost anything that happens in your AWS account, you can trigger Lambda off. So this really lets you think outside the box and come up with really creative ways of solving customer problems. Because all of these things that run Lambda runs your code and your business logic. And that can be PowerShell. So this is a really crazy large capability just because you know PowerShell. So let's look a little bit more detail on some of the more common ones that I know I've sort of used. So Cloudwatch Events can also schedule executions. So scheduled tasks, no one particularly likes managing scheduled tasks. So this can do it for you. This can trigger your Lambda function on a schedule, on a cron expression. And this is highly available. It's triggering, and let's face it, likely millions of things in the cloud today. So this can schedule the execution of your Lambda function if you have that need. Simple queue service. I talked about this before. It enables you to decouple microservices and build very loosely coupled systems. This triggers Lambda for you. Now, when you read the documentation for this, it will actually say that the SQS team polls your Lambda function for you and synchronously invokes your Lambda on your behalf. So you are not writing the poller. The Lambda service team has the poller. And to you, as a customer, it's an event. It's an asynchronous event. So SQS, as I stated, exceptions will cause a message to go back into the queue. So if you are processing a message and you call a downstream API, and that API is offline and down, and you throw an exception from your Lambda function saying I can't talk to it, the message goes back into a queue, and you can replay the message all over again, and you've done nothing to do it, which is awesome. And if it fails too many times, that can go into a dead letter queue, and you can have an alarm that says, if I ever have a message in this queue, go and send me an email, send me an SMS. So now when something actually fails in your system, even though you've repeatedly tried to fix it, now you're getting an actual error in your email, your SMS, or any other platform downstream when something has actually gone wrong. Not a temporarily brief outage to an API, a continued outage to an API could actually cause that alarm. Amazon Step Functions. This is a service I know the team I'm on and our sister teams use very heavily. It allows you to define logical workflows in a JSON language. And the Step Functions service controls the execution of that workflow for you. And that workflow can have logic, branching, retry capabilities, parallel executions, and it can trigger Lambda at any step of your workflow for you. So Kurt kind of talked about this a little bit in his talk yesterday. You can kind of use an analogy of a pipeline for this. PowerShell function A does work A, and you pipe that through the pipeline to PowerShell function B. PowerShell function B says, if my record says hello, go and do PowerShell function C. Otherwise, do PowerShell function Z. Logical workflows, right? We're building monolithic PowerShell scripts that are hard to test. The logic can be kind of confusing at times. So this lets you define your logic in the cloud using Lambda functions as all your individual execution points. And all of that is taken care of, scales independently, and you don't think about any of it. So this is a really great service for building logical workflows. An API gateway is another really good one. So this is a managed REST service where you can build REST APIs or WebSockets, so long-lived connections, with a completely managed offering that you can supply Swagger documentation to define your API. So if you know Swagger, you can use that with API Gateway to deploy an API. You can use rate limiting with customer keys. You can use authentication mechanisms such as SAML or AWS Signature v4, which for the record is the same authentication mechanism used by every single public AWS service that you call through the SDKs. So you can use that same authentication mechanism on your own API backed by PowerShell in Lambda. And you have no web server fleets, no load balancers, no firewall holes, none of that. You just got some cloud resources that scales for you. All right, 50 minutes in. It's been a lot of content so far. Any questions at this point? Yes? So the tooling, when this was launched, so the question was, why do you have to compile a .NET function, I'm presuming? Yeah. So when this was released in September last year, the custom runtime support, which was launched at reInvent last year, hadn't been launched. And so adding a new runtime from scratch is a very large undertaking. This meant we can use the existing .NET Core runtime and shell out to PowerShell, which is actually a very performant way of running PowerShell. So it actually gives us a lot of capabilities that we may not have had if it was a native PowerShell runtime. But there is a custom runtime feature in Lambda now where anyone can bring any language you want and build your own runtimes in Lambda. And you could totally go and build your own custom PowerShell runtime if you wanted to. The gap there, you can do it, but now you own it. So if you build your own custom runtime, you own your custom runtime, which kind of defeats the whole purpose of going serverless in the first place. So I wouldn't recommend it, but hey, whatever floats your boat. So what have we learned? We've demonstrated PowerShell Lambda. This is just PowerShell running in the cloud. There's no fanciness really going on. Serverless really lets you focus in on your customer. You're not managing servers or hardware or operating systems or all of those things I've mentioned a few times, and I'm going to mention it again. Serverless lets you focus on your business logic and what differentiates your business from the next business and really drives that to a T. Event-driven computing allows you to stop paying for idle. It allows you to build loosely coupled platforms that scale independently, and you're not paying for idle. I'm going to drive that one home too. Why run a server 24 hours a day to run a 5-minute task? That's just wasting money. You're throwing it out the window at your electrical company and your cooling systems. So, at this point, I kind of want to shift gears a bit and show you this in action. Because there's a lot of information about how you could do something, why you want to do something. And I'm sure you'd probably actually want to see this actually in use so you can kind of get an idea of those benefits. So let's demonstrate a REST API. Completely serverless REST API, PowerShell-based, deployed through CloudFormation, scaling independently. And we're going to do it for PowerShell module translations. So we all have very different jobs, doing very different things, but we all use the PowerShell gallery. And that's in English. And what if your company was all across the world and you had people that wanted the descriptions of modules in other languages? So I'm going to demonstrate what it would look like to do that today. So what are my requirements? I want one API where if I hand in a language and the name of a module, I want the translated version of the description back, which you could do real time. You could kind of real time get that in, do a find module, call. We're going to use Amazon Translate, which is a translation service. You feed it a source language, a target language, and text, and it translates it for you and hands it back. So you could kind of do this in real time. It wouldn't be super quick, but you could. But this next one you couldn't, because in this one, I want to retrieve all modules for a language. So give me French. Give me all the modules in French. So I'm clearly going to have to do this calculations and translations in advance. Oh, and I also want to let me query them. Maybe I've got a specific word I'm looking for in module descriptions. So given a language and a word, a string, go and find me all the modules that have that string inside of it. At its bare minimum, in the serverless world, I have a Lambda function that finds modules, and for every module sends a JSON message to SNS. That is all that function does. 3 things. My translation layer has 3 things too. Query my data store, and if I haven't already translated that module, translate it and save it to my data store. Now, if you think about what this would look like in a scheduled task for all over 4,500 modules on the gallery, if you're doing 10 languages to translate to, there's a minimum for the first execution, 45,000 API calls to your data store, minimum of 45,000 calls to the translation service, and you may well get rate limited by them, and 45,000 calls to save that record to your data store. All the logical handling of that code to run it on a Windows server with all that operational overhead of a Windows server, and all the API calls you're making, which could time out, your internet might drop. It's not an insignificant amount of code to make that into a really good, strong production code base for your company. If you look at this, there's really nothing happening. I've got 10 records at a time. I'm doing 3 API calls for each thing. So I've got a maximum of 30 API calls per execution of Lambda. And then my API side, I've got 3 queries in my API. So my API has an if statement, get a value from Dynamo database, return it back to my customer. Query Dynamo for all of these things and return them back to my customer. So again, this code here is very minimal. So in a serverless world, this is what I put together. So I'm using Cloudwatch Events to schedule the execution of the start of my workflow. This is the function that will go to the gallery, get all the modules, and just hand them off to a simple notification service. That's all it does. Simple notification service will scale that out to multiple SQS queues, 1 per language. 2 if I want 2 languages, 10 if I want 10, and so forth. It will handle that for me, and I don't have to think about it. The second Lambda function in the middle there does that translation. For every record I receive, query my data store, translate, save, not a whole lot of work. And I'm using Dynamodb as my data store. Now let's just kind of stop here for a second and talk about this. The start of this workflow. In this world, I have a scheduled highly available service triggering a Lambda function in a highly available platform that scales independently, and I don't think about it. In a traditional environment, I have hardware that's racked, and a hypervisor, and a server, and an OS, and a domain, and antivirus agents, and monitoring agents, and definitions, and zero-day patches, and monthly patches, and all of that fun operational work just to run a few lines of PowerShell. And my data store, here's a big one. Most companies, and it goes for, I know the last company I was in, would likely use SQL Server for this. And have a think of what goes into managing SQL Server. Multiple servers running a failover cluster with specific LUNs configured in your data store attached to those servers, with witnesses, with SQL Server installations, with SQL Server patching, with version upgrades, which what language of SQL Server you're going to run it in. It may not even be your team. It may be the SQL team. So now you're dependent on their workload to get your application deployed. That could delay you by months. But that's also a very large undertaking by that team just to run a database that needs key value pairs. In Dynamodb, this is a serverless data store. You can give it different amount of throughput, or you can pay per request. It's sub 10 milliseconds latency on per request. It's an API call to stand it up. It's an API call to turn on point-in-time backups. It's an API call to turn on global replication of your data store. It can be multi-mastered in multi-regions. And it's an API call. And all of that underlying management is done for me. So just to get to the point of storing my data in a database, I've saved a whole lot of operational burden. And I can do it all myself with some PowerShell and some YAML. So the API side of this, on your right, this is a managed REST API service, as I said, that is backed by PowerShell in Lambda. So you define a Swagger template, some YAML or some JSON code for your cloud formation that you're going to deploy, some lines of PowerShell to do the actual work, deploy it to your account, and it scales for you. Now, what does this look like in a traditional environment? How many of you have direct access to your web servers? Yeah, not many. And how many of you would want to write an ASP.NET application to deploy to an IIS fleet to do this work? I know I wouldn't. Who wants to run IIS? Now, that IIS web server fleet, how does it scale when your load goes from nothing to tens of millions of executions per day? You've had to pre-purchase all that hardware because you needed to know that you were going to scale to that level of work. Your web servers come in and out of service as you patch them. They have to be added and removed from load balancers. They have security patching. IIS takes a long time to install. You need to know ASP.NET. You need to deploy certificates. You need to rotate your certificates. So again, just by choosing to not deploy to a traditional environment, you've saved your other team, your web developers, a whole lot of work. And you're not reliant on them to deploy your service because you're doing it all in PowerShell. Additionally, the other part of that is your web server talks to a database. Your web server is probably in a DMZ. Your database is probably not. So you also need your networking team to punch holes from every single web server into your corporate network. It's what traditional IT has done for many, many, many years. It's not the most secure thing to do. Someone hacks your web server. They have a port to get access to your internal corporate network on. This is why we patch everything. This is why we hate patching everything. So why do it? So if you do it all yourself, You can control your deployment speeds, you can control the code, you can control every part of this pipeline in your team today in production. So as me as a developer, I own these 4 things. I own 3 Lambda functions and a CloudFormation template. The first Lambda function is like 20 lines of code. The second, I think, was about 70 because I'm splashing everywhere and I've got comments. The third was about 200, 250 because Dynamo, I need to shell out to .NET to talk to Dynamo. But again, 300, so what, 380 lines of code total. That's not much. My CloudFormation template was actually longer than the amount of PowerShell I had to write. It was something like 380 lines of YAML. But again, that's all in source control. This can be deployed through a CI/CD pipeline, and I own all of it. I don't rely on other people. I don't rely on database teams, on networking teams, on firewall teams, on web service teams, on teams racking hardware in my data center, on security people standing in front of my data center. I can do it all myself today. So let's look at it. Let's have a look at what actually happens. Oh. And it disconnected again. Now while it's loading, to that point of Dynamodb, the AWS PowerShell module, and we're going to talk about this actually at 2 p.m. a bit more today. There's like 5,800 commandlets in that module. It's a very large module. And there are gaps in that 5,800 commandlets. Like we don't have commandlets for DynamoDB. But the module ships the entire .NET SDK with it. So you can shell to .NET and do literally everything a .NET developer can do from PowerShell. So if there's not a command for what you're trying to do, you can still do it, you just shell out to .NET. We've all stood up .NET objects before, I'm sure. So, module translation. Let's start by looking at the Lambda functions. Here's the starting one. All right, I've got 3 required statements. I need the PowerShell module from AWS to talk to SNS down here. I need package management and PowerShell get because I'm going to be talking to the PowerShell gallery. I'm going to allow a prefix so I can actually horizontally scale the start of my workflow as well. So what am I doing? I'm finding a module, and for every module on the gallery, I'm sending a JSON to SNS, and my job is done. That's not a whole lot of code. I don't even have error handling because why bother? The second part of this that performs my translation, again, this code will be on GitHub, so you'll be able to see it there. This has a little bit more. As I mentioned, at DynamoDB, I need to use some .NET to shell out to this. Now, if you want to use DynamoDB from PowerShell, there's an AWS .NET Developer Center website. I'll happily tweet out the link, but aws.amazon.com/net, N-E-T. On there are code samples, and on the code samples, there are PowerShell code samples as well. And those PowerShell samples include a whole bunch of probably all the things you'll ever want to do to talk to DynamoDB from PowerShell. So it's a really great data store. You do have to use .NET, but there's a whole bunch of user story documentation out there of exactly the code you can copy paste to go and do that. So as before, every SQS message, because I'm using SQS to do this, and every SNS record, because this is the same template you saw before, I'm going to start this entire block here is all to run a get item against Dynamo. So go and get a record from Dynamo database. Have already converted that version before. If yes, get out now. If not, use a single commandlet to convert the description from English to whatever target language I'm going to define in this function. So that's a simple API call to AWS. It gives you translated text in the background and job done. And then the next bit of code is simply going to save that to my Dynamo data store. So again, I'm only really doing 3 API actions, maybe, for every record that comes in. Kind of the same thing goes for my translation, my API. So this will run inside API Gateway from Lambda. Same thing, I'm defining some default responses. This is a web request, this is a REST API. So I'm going to hand back a status code, a body and a header. I'm going to just default to I don't have it. Some DynamoDB things, 3 if statements, and a response. And those if statements are kind of as small as you'd expect. I'm just going to go through one of them. But as before, code to simply get a record from Dynamo database. If I have a record, overwrite my status code and my body and my header, and then it gets returned. So 3 if statements, and I'm sure everyone in this room can write 3 if statements. So you can build your own API in API Gateway and do this exact same thing today in production. So let's invoke this and kind of walk through what happens in the UI so you can see the flow of data. So I'm just going to trigger this for some letters in AWS because I work for them. And let's go and look at what's kind of happening through the UI. So I triggered a Lambda function there like 7 times. And I triggered that. You'll note that when I triggered earlier, I triggered with a response request type execution. And I was waiting for a response from my Lambda function because I wanted the output. I triggered these ones as an event. So just like it would in the asynchronous workflow, I just said, go run this thing and just go away, go do your thing. So that was really quick to invoke 7 times because I wasn't waiting for any responses. So I started my translation workflow. It maps to this Lambda function. And I'm just going to scroll down here quickly to show you the configuration where I've configured my SNS topic. So you would have seen in the code the environment variable. This code will find all the modules on the gallery based on that prefix, send a message to this SNS topic, and walk away. So let's go to this SNS topic and have a look. So my translation module topic here has 5 subscribers to it, 5 SQS queues. And you can see from the name of these endpoints, if you can read that, IT, DE, JA, FR, and ES. I'm going to translate to those 5 languages. So this message comes in, it's a simple JSON record. It's going to be sent to all 5 queues, which are going to start being processed by Lambda. So let's go over to SQS and follow that bouncing ball through the line. Now here's a fun. Here's a few thousand executions of Lambda happening right now in PowerShell. All right, so PowerShell in Lambda here had no executions at all before I started. I triggered this. There's something, I think, from memory, around 800 or so modules I'm going to convert in this demo. And this is happening right now, invoking thousands of Lambda functions to go and do those translations for me. And some of these are failing. I'm actually hitting API limits right now, and I don't care because it's just going to put the message back in my queue and get processed all over again. So I don't have exception handling. I'm just letting that fail. I'm letting SQS handle that retry capability for me. So these are going to go to a Lambda function. And you can see here I've got a Lambda trigger, which is, they're all actually feeding into the same Lambda function as well. That Lambda function does that conversion that I demonstrated, and these all go into DynamoDB. So I have a Dynamo table here. It's my translation table. And I have a whole bunch of records already coming in. So DynamoDB, I've set this up to pay per request. This means every request, there's a charge associated with it. But I don't need to define how much throughput I want, because I want this to be in a serverless fashion. And I don't want to think about my throughput. I don't want to think, you know what, I'm going to get 1,000 requests now, and then in an hour's time I want you to scale down because I want low requests. I don't want to think about that. Just go use whatever you need to use to make this thing happen. And I'll own that because if my service is popular, great, scale up, do the work. So as I said, this is a key value store service. You save records in JSON, and you can see in the text format here, and this is the JSON record I saved for this record. So JSON in, JSON out, as most things are with web requests. So I'm loading all this data into my data store, and this is all happening for me at a few thousand executions. Let's go look at my API. So this module translation API here, and I've simply got those 3 methods that you saw in my if statements. If, find language query, if get language, and if get language name. These get mapped back to a Lambda function on the right. So and this is all deployed through code, and the code will be on GitHub. So I've got 3 exposed APIs here, and now I can go and call these from PowerShell and see how quick this is to get responses. So go back to presentation mode, and let's query to get my UI. my URI, so it's my REST API endpoint. I've got my 5 language codes I can query for. Let's start with French for the AWS PowerShell module. Again, the first invocation has a cold start associated with it, so this first execution will take a few seconds to run, but subsequent ones will be a lot quicker. This scales out for me, and there's my translation in French. Now, to sort of demonstrate the speed, there's the speed in Japanese. So this is a really quick API, and this is in the hundreds of milliseconds for each request. If I can hit this 1,000 times, it'll spin up however many Lambda containers it needs to serve those 1,000 requests. Yeah, this is just a PowerShell object, right? It's a REST API. So that's a single module, and I can call that for any of those modules I've translated. And as we saw, what about, give me all the modules in French. So this will take a couple of seconds. There's 810 responses already. That's a query to a Dynamo store, giving me 810 responses. And to sort of prove, here's the first 10 with the names and descriptions. And so I did actually retrieve 810 responses with translated descriptions. And the other cool one was I wanted to be able to query this with a word. So I don't speak French. I'm not going to even try and pronounce that in French, even though it should be easy. But if I search for that word in French, there's all the modules that have that in French. And you can see these APIs are like less than a second to execute. And these are doing standard queries against a Dynamo data store. I'm not using anything fancy capabilities here. This is all just standard serverless-based development in AWS. So that's pretty quick. And I think this is cool because it demonstrates that you, knowing PowerShell, can go and build these APIs and build all these things right now. You don't have to involve other teams. You don't have to worry about all the hardware and OSs. And this is all just running in the cloud, and I kind of don't have to think about any of it. It's just going to run for me. Any questions about that? Cool. So let's go back to the slides. So I'm a little bit early, but that's OK. So let's wrap up. PowerShell is in Lambda. Production launched in September last year. Runs PowerShell core. Runs any version of PowerShell core that you want to specify when you publish your Lambda function. It's just PowerShell. It's just running on a server you manage. You know PowerShell, you know JSON, you know YAML. You can go and build all these things right now. Go and read a little bit about AWS services, and you can go and build these serverless, event-driven applications today with your existing skill sets. And by doing so, you're moving your focus even further to your customer. You're really focusing on what your customer needs, what you can do for them. You can deliver solutions faster. You don't need other teams. You don't need to think about how much hardware you need. You're really just focusing on the explicit business requirement that you're trying to deliver for your customer. And I'm going to call you a PowerShell developer now because bad luck. You write PowerShell code, you run it in production, you are a developer. So this is something I've been saying to people kind of all week and for a while. You, as a PowerShell developer, have the access to the same APIs, technologies, and capabilities in AWS as developers that use .NET, Go, Java, Node, Python, Ruby, or any of the other languages against AWS. You know PowerShell, you can do all the same things that all of those developers can do. So think about what is built in serverless today. If you go to the Lambda website, go and look at what companies are doing. Let's process billions of IoT data points in Lambda in serverless. Let's go and process hundreds of millions of log records to pull out specific data points. You know PowerShell, you can do it, right? Think outside the box. Think what you can do with this technology to really drive your business. You don't need to have a computer science degree. You don't need to write compiled software. You write PowerShell, you can do it all right now using any AWS API you want. And that is a really powerful place to be. So thank you. So the question was, can you use SAM local development? So SAM is the serverless application model. This is a custom, handcrafted, open-sourced CLI tool that lives over the top of CloudFormation and sort of serverless development. SAM local basically allows you to write a Lambda function, invoke it in a local Lambda, in a local Docker container that simulates a Lambda execution environment. And yes, it runs in SAM local right now. You can use that to develop and test Lambda functions in PowerShell. Yep. And there's a good point to that. Any example you find on the internet for Lambda, for serverless, written in any language you want, you can translate that to PowerShell and do it yourself. So anytime you see a blog that talks about how to do something in Node.js or Python against Lambda, you can do it all as well. Right? That's just an example in one language. What I've talked about today isn't explicit to PowerShell. All those serverless benefits run for any language, so any example in any language also works in PowerShell. So to see what's happening at every step of the way through your code, I've never tried. I've never tried using transcribe. Now, remember, this is PowerShell hosted inside of a C# application.
Yeah, I'm not saying you
So Lee probably has more information about whether that would work than me, but and it's anything you do today, like if you write verbose all the way through a script to get your outputs so you can capture things as they're going through, that'll work. So even though it may not be transcription, which might work, I've never tried, but you could just write everything out to your logs. Now, a note on logs. Writing to logs is very powerful, clearly, to troubleshoot what you're doing. When you deploy to production, you may not want quite as much verbosity in your code. Think about that every time you write to logs. It is doing a slight performance hit to your execution. And in Lambda, if you're processing billions and billions and billions of records, that like 10 milliseconds adds up to a lot of execution time. And as you're paying per 100 milliseconds, that can add up to dollars in your pocket that you're saving by not writing logs in production. No other questions, so thank you very much. Hope you've learned a lot. And I will say at 2 o'clock today, Steve Roberts and I, who's a technical evangelist, will be talking about PowerShell on AWS in general, and more about some of the other management capabilities that you can do with other services. And tomorrow at 10 o'clock, I'll be talking about one of our log agents, which is fully open sourced, which can help you get things off your systems no matter where they're running, shovel them up to AWS, and then process them using techniques like PowerShell in Lambda today. So that's at 10 o'clock tomorrow. Thank you very much.